Okay, you guys, I'm gonna hold this up today because I'm trying an experiment because this thing always cuts out on me. So I'm gonna hold it up. All right. Find the 6 trig functions of the angle A in the triangle. How many of you guys got this? In order to do it, we have to know the third side, right? What did the third side come out to be? How do I find it? Okay, a squared plus b squared equals c squared. I use the Pythagorean theorem. The two legs are a and b, right? It doesn't matter which one's which. So I'm going to do 15 squared minus 10 squared, and then take the square root of that. What does that come out to be? What did you guys get for b? 11.9? I'm going to use the radical of it. So 225 minus 100, right? Which is 125, right? That's 5 root 5. Is that right? Well, do you guys remember that if you have 125, the square root of it, you break it down. 5 times 25 is 125. 5 is a prime number, so we're done there. But 25 can be broken down into 5 times 5. And so I've broken it down into its prime numbers. Okay? And any pair of numbers, we have 5 is 3 times. But any pair of numbers, you can take the square root of that. Because, I mean, 5 times 5 is 25, and the square root of 25 is what? 5. And then any loners, I call them loners, anything left over goes back inside the radical. And so that reduces to 5 root 5. Okay? Now, you're going to have to actually know that to a lot of these assignments that we're going to be coming up. But 5 root 5, okay, is the length of this side right over here. Okay, everybody got that? Okay, so that's that side. Now, I've got to find the sine, the cosine, the tangent, sine of, which one does they? Okay, so I have to find the sine of A, the cosine of A, the tangent of A, the cosecant of A, the secant of A, and the cotangent of A. So how do I find those? How do I find each one of those? Okay, how do I find the sine of A? What's it defined to be? Opposite over hypotenuse. So which side's opposite of A? 10, and hypotenuse is 15. So I put 10/15, but that reduces to what? 2/3. We got that? And then the cosine of A. What is the cosine of A? Adjacent over hypotenuse. 5 root 5 over 15, right? What does that reduce to be? 5 and 15, simplify? Yeah, so root 5 over 3, because 5 will go 3 times. So there's that one. Then the tangent would be what over what? Opposite over adjacent. So it'd be 10 over 5 root 5. Which 5 will go into 10. Here's the with this answer, and I didn't really talk about this last time, is it has the radical in the denominator. What do you do when you have a radical in the denominator? Do you guys remember? If I have 2 over root 5, I'm going to write it right over here. I multiply by what? Root 5 over root 5. This is called rationalizing the denominator. So you don't have a radical in the denominator anymore. If I do that, on the top I'm going to get 2 times the square root of 5 because I multiplied 2 times the square root of 5. And then I times root 5 by root 5. What do I get when I do that? 5. Because 5 times 5 is 25, and you take the square root of it and you get 5. But anytime you times two radicals together that are the same, or two square roots together that are the same, you're just going to get um, that number. Okay, so tangent is equal to 2 root 5 over 3. All right, now the last three, we can get those by doing what? The reciprocals, right? Cosecant is a reciprocal of sine, so instead of 2/3, halves. Secant, gotta rationalize that. Do you guys know what we'd get? 3 root 5, right? You get that one in your head now that you know kind of the pattern. 5 over 5. And then the cotangent would be 3 over 5, right? And I have bottom by what? Just root 5. And if I times the top by root 5, I would get, and if I 5, I'd get this 10. Okay? And so there are my 6 trig functions. Kind of a long problem, but I just wanted to review what you guys did last time and go over the radical part of it. All right. Okay, our itinerary shows that we're going to turn in lesson 6-1 right now. We're going to grade it. So get it out. Lesson 6-1. Oh, I'm at 5-1. I wrote 6-1 everywhere back there. We're on chapter 5, aren't we? Will you fix that, Bryce? Thank you. Okay. Someone tell me how many problems we have. I'm going to turn this off while we correct the assignment. Let's answer questions, you guys, on the last assignment. I'll answer a couple. Anybody got one? Yeah. Sadie and Lauren, and you guys have the same one or not? Okay. Sadie, what do you have? Let's write these down. 24. What do you have, Lauren? 13. Michaela? 24. And do you have one of these same ones? Okay. 25. You guys want to go over those three? All right. You guys on? Okay. You guys, it's important that you know how to do this on your calculator. I'm going to show you this one on the calculator. These are really easy. I didn't show you last time though, so you can see why you didn't get them. On 24, on A, all you have to do is, first of all, you need to make sure your modes. Everybody do this because I didn't go over this last time. I need you to know how to do this on the calculator. Everybody get out a calculator and push your mode button. When you got it, hold up your calculator and let me see that you got it. Mode. Okay, hit your mode button. I want you to make sure down on the third line where it says radian degrees that degrees is chosen because this angle that we're dealing with is in degrees. If you have it in radians and it was in degrees, then you are going to get it wrong, right? Okay, so we want the answer in degrees. Okay, so go back to your home screen by hitting second in mode. Clear anything out of there. And it wants you to find the sine of 52 degrees, 47 minutes. So 52 degrees, 47 minutes. Well, you guys, I know the calculator has a minutes thing on here, but not a seconds thing. I think it's easier just this is 52 plus 47 over 60. So what I would do is I'd hit the sine button. It's right here. I would put 52 plus 47 divided by 60. And then I would close the parentheses like that. And that's going to calculate it for you. .796. I'd round it to 3 decimal places. 0.796. They have a what? Yeah, that's 47 minutes. Yeah, isn't that what I put? But I put it in the it does have a minutes thing on here. If you go to second angle, let's see if we get the same answer. It has one right up there under number 2. It has a degree mark and a thing, but you don't really need to use it for this. Let's see if it works. Because it already assumes that it's in degrees, but so if we go sine of 52 and then second angle degrees and then 47 and then second and angle 2. I don't know if this is going to work this way or not. Okay, we get the same thing. It doesn't have a seconds button though, is what I'm saying. Okay? Which one's shorter though?
The second one.
I thought the first way was a lot shorter. I think the first way is a lot shorter. All you have to do is write 47 divided by 60. Okay, well, on C when there's 3 not, okay, tangent of 88 degrees, 22 minutes and 45 seconds. So I'm going to go hit tangent. What was it? What was the degrees again? Huh? 88 plus what? 22 divided by what? No, what does it say? 22 degrees. So 22 divided by what, you guys? 60 plus what? 45 divided by what? 3,600. Close parenthesis. And that should be it. 35.34 is the answer. Okay? Okay. All right. And you guys, how do you put cotangent? That's the question. There's no cotangent button on there. Lauren. Nope, you don't hit the second button. You guys, I want to distinguish this. That's a common error. You guys, everybody. I mean, almost every one of you guys have done the same thing. Because above it, it has like a sign with a -1. That means sine inverse, cosine inverse, and tangent inverse. We only use those buttons when we're looking for, when we're given a trig function and we're looking for the angle in degrees or the angle in radians. Okay, that is an inverse. We'll be learning about those later on, not today. What we have to do is we have to use the reciprocal function because the cotangent and the tangent are reciprocals of each other. They are not inverses of one another. That's an inverse button right there, okay? Does that make sense? It's a common error. I get that. I mean, still, some of you guys will probably think that. What you have to do, any other ideas? Yes, Michaela? Yep, 1 divided by the tangent. And how many degrees was it? 36 degrees. That's what you'd put in your calculator for cotangent. 1.37. 1.376 if you round it to 3 decimal places. Okay? Now, what would you do if you're going to do a secant or a cosecant? 1 over cosine or 1 over sine, depending on which one you're doing, right? Everybody got that? That's how you put those into your calculator. All right, that was problem number what? 24. What's the next problem? 13. Okay, the slope of a line is the ratio of the change of y to the change of x. Name the trigonometric ratio of theta that equals the slope of line M. Okay. All right, well, basically what it's saying is this. If here's the x-axis, I mean, here's the y-axis, here's the x-axis, and if you had this triangle out here like this, it's saying something like this, we can assume theta is right there, right? This is the x distance, this is the y distance to get to this point right here. Okay, if And when you calculate slope, what do you do to calculate slope? Slope of a line is the change in y values, right? Um, remember, if this point, if you were finding the slope between this point right down here and this point right up here, okay, you would go y2 minus y1 over x2 minus x1, right? In other words, y over x. If you know the distance, we already know the distance is called x, and the distance right here is y, and that's the change in the value, right? So if this is theta, and this is y and x, how do we say that? What do we say if it's this side and this side? What do we call that tangent function? I mean, thank you. What do we call that trig function is what I meant to say. It's the tangent, isn't it? Tangent of theta is equal to opposite over adjacent, which is y over x, which is the same thing as slope. So it's the tangent function. Okay? All right, what's the next question? What was the last one we... 25. Okay, so we got 25. Use the table function on a graphing calculator to complete the table. Round the values to 3 decimal places. So do you guys know how to do that now that we went over that calculator one? All you have to do is do the sine of 72 degrees, the sine of 74 degrees, sine of 76 degrees. What did you guys get when you hit the sine of 76 degrees? 0.970, right? 78 degrees, 0.978. All you have to do is stick those in your calculator and you get them. Yeah. And then part A says, what value does sine of theta approach as theta approaches 90 degrees? What number are you getting closer and closer to, you guys? You look at it. You guys can tell. I think someone said it. And what is cosine getting closer and closer to is the higher the closer you get to 90 degrees. So if you fill out the table, I think you'll see those. Michaela. Which one? 23. Yeah. Okay, let's talk about 23. Okay, 23 says, if tangent of theta equals 1.3, find the value of the cotangent of 90 minus theta. Okay, this is 23. Tangent of theta equals, what does it say, 1.3? And cotangent of theta equals 90 minus theta. Do you guys remember when we talked about cofunctions? For example, if I had the tangent of 73 degrees, that's equal to what? The cotangent of what? It's equal to the cotangent of, remember complementary angles? What are complementary angles? They add up to 90. 73 and what make 90? 17 degrees. So this angle plus this angle have to add up to 17. If you have a tangent of one and the cotangent of the other, those are cofunctions. Well, right here it's saying that the tangent of theta is 1.3. So the cotangent of 90 minus theta, 90 minus theta is the complement of theta, right? Just like 73, 90 minus 70, what's 90 minus 73, you guys? 17. If 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 73 was right here, and this said 90 minus 73, I'd get 17. In other words, it's saying that tangent and the cotangent are cofunctions of one another. So if the tangent's equal to 1.3, the cotangent of 90 minus theta is also 1.3. If the value of the tangent of theta is 1.3, then the value of the cotangent of theta is also 1.3. The value of the cotangent of 90 minus theta, I should say. I wrote that wrong. Should have written it like this. The cotangent of 90 minus theta. Sorry. So if theta and 90 minus theta are complementary angles, therefore they both have the same value. They're both 1.3. I wouldn't worry about it too much. Okay? All right, any other questions? Kyla? I've just made something up. Give me an angle between 0 and 90. Huh? 20. If tangent's 20 degrees, then 90 minus 20 is 70. That means those two are equal. And see, I have 20 is equal to 90 minus 20. 90 minus 20, they're not equal, but they're cofunctions. If one of these is tangent, one of these is cotangent. No. Well, it doesn't matter. We don't know what theta is. If we knew what theta was, we'd know, but we don't know what theta is. We're just saying the tangent of some angle, we don't know what it is 1.3. Therefore, its cofunction is also 1.3. Well, we've been substituting numbers in. We don't know what theta is. Not this number has to equal 90. This number right here is the angle. This theta right here represents the angle. So if you made up an angle like 20 degrees, if theta was 20, 90 minus 20 is 70. So that would be 20 and that would be 70. And they were cofunctions, right? But what we're saying, tangent of an angle and the cotangent of 90 minus the angle are going to have the same value. No, it's not saying that angle is 1.3. It's just saying the value of tangent of whatever the angle is 1.3. So tangent of the angle is 1.3, therefore its cofunction is 1.3. Think about that one for a little bit. Okay? All right, next. We done? Okay. We'll turn that assignment in next time. All right, now, today, we are going to do lesson. No what, Bryce? We missed what?
Dude, because you were teaching math, you made us so busy. Yeah, gosh, Mr. King.
Well, you could have done it this morning. Why didn't you do it this morning? Well, that was your own fault. Hey, you guys didn't miss it. You were here.
I didn't even get a screenshot.
12, 12, 12, 12, 12. Would it make you guys all feel better if I put the clock at 12,
Yeah.
12?
And then write 12, 12, 12 underneath it, and I'll take a picture.
Here. Fits in or ability to say that long of a name every time. We're going to the first half of lesson 5-3 today. The objective is to find the trig values using a unit circle. Hey, by the way, what does the word unit mean? Means one, right? Okay, there are two ways. Don't write this down, just this green part down. Okay, that's fine if you did. It didn't hurt to write it down. But there are two ways to define trigonometry values. I should have probably wrote trigonometric values. But number one is by right triangles, and that's what we just learned, right? Everybody knows SOHCAHTOA, right? Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. The second way is by using unit circles. Now, this is the way you guys really need to understand for calculus. Mr. Esplin is going to make you take a quiz at the very first of the year. Next year when you take calculus from me. But if you take calculus at some point in your life, like in college, you'll need to know this. Okay, but the better you know your unit circle, the easier calculus is going to be on the trig parts of it. Okay, so he's going to have you fill out a blank unit circle test, and we'll do that in here too. We're going to have in fact, we'll have that unit circle test before the end of the quarter. You guys you want help on your grade? This quarter. You want help on your grade? It's worth 63 or 66 points. 1 point for each blank. Actually, I half it, so it's only worth about 30-something points. But it's not extra credit. But it's easy. It's easy. It's easy. So you can. Last year when I gave this test to my pre-calculus classes, over half the kids got 100%. And the kids that missed, Yeah, that's right. I gave it an algebra 2 last. How many of you guys from me? Yeah. Okay. All right. So we're gonna take here. Here we go. What is a unit circle? It is a circle with a radius of 1 and its center at 0, comma 0 on a coordinate plane. And I even drew a picture for you. Okay? A unit circle has a radius of 1. Anywhere you draw a radius, how long is each radius? 1 unit long, right? Each of those blue lines are 1 unit long. We don't know what that unit is. It could be anything. It could be an inch. It could be a foot. It could be a yard. It could be a mile. Okay? Your unit circle can be any. So, it is a circle with a radius of 1 and its center at 0, comma 0 on a coordinate plane. Give you a second to write that down. If you're doing something else, put it down for a second. I need you guys to see this, okay? I need to kind of teach you this right here, okay? This is an example of an angle on the unit circle. Okay, on the unit circle, you have, if you were to draw an angle theta, okay, in other words, I'm going to turn it some measure of degree, and we're going to start off with an angle in the first quadrant, an angle less than 90 degrees. Yes, Lauren? You know what? It's up to you. Um, if it helps you, I don't know if it will or not when you go back and look at it. You can always look at it in the book too. Okay? So just watch it. I think it's more important you watch this and listen. Okay, right here, um, this right here, if we draw an angle right up here, it crosses the unit circle, and we call that point x, y, because we don't know what it is right now. We're just using a generic name for it, x, comma, y. What's the radius of that? What's this distance from here to here, you guys? Did you say that because I wrote it already? Why? Because it's a unit circle, and the radius of every unit circle is 1. Thank you. Okay, now, we always have an x distance. Okay, that's that x distance right there, and the y distance. Okay, and that's what we call point x comma y. Now, I could write the equation using the Pythagorean theorem, can't I? To find, I can insert these in the Pythagorean theorem. A squared plus b squared equals c squared, right? The legs are x and y, so I put x squared plus y squared, and the radius is 1. 1 squared is 1, right? So x squared plus y squared equals 1 is an equation I can write for that. And I can find different trig functions on here using that information right there. Okay. For example, a 45-degree angle. Say I have a unit circle, and let's say we have a 45-degree angle on it. Okay. I don't know what x and y are, but what do I know about x and y on a 45-degree angle? They're the same length, right? And so I can write an equation kind of like this one right here. X squared plus x squared, because I can say that x and y are equal, so I can insert one for the other, equals 1 squared. That's 2x squared equals 1. Divide by 2, you get x squared equals 1/2. Take the square root of both sides, you get the square root of 1/2, which is square root of 1 is 1, and the square root of 2 is square root of 2, right? And then if I rationalize it by timesing the top and bottom by square root of 2, I'm going to get 1 times the square root of 2 is square root 2. And square root 2 times square root 2 is 2. Therefore, the x-coordinate is square root 2 over 2, and the y-coordinate is square root 2 over 2, right? Okay, this is kind of the foundations of a unit circle. I'm going to give each one of you a unit circle right now. You will notice on your unit circle that it has degrees going all the way around, and it has what we call the common angles. 30-degree angle is a common angle. A 45-degree angle is a common angle. And a 60 is a multiple of 30, so it's a common angle. and 90 degrees is a common angle. And then multiples of those going clear around here are on there. Notice it doesn't have anything like 87 degrees. That's not a common angle. Okay? So it just has the common angles. And you're going to use the common angles up with a lot of stuff here. Okay? And you'll notice every one of those works out in the Pythagorean theorem. Okay? And remember 30, 60, 90 degree triangles, you guys? Every 30 degree angle and every 60 degree angle on here can be made into a 30, 60, 90 degree triangle. And remember what we learned about right triangles 30, 60, 90 degree triangles last time? Let's say I have this right here. Let's say this is a 60 degree angle. This is a 30 degree angle. I taught you that a 30, 60, 90 degree triangle is half of what? The half of what? What kind of triangle is this half of? Equilateral. It's half of an equilateral triangle. And so if this over here is 1 unit, if every side of this is 1 unit, what is this side right here going to be right here, guys? It's going to be half of a unit. And this unit right here is the short leg times the square root of 3, right? Well, if you times the square root of 3 times 1/2, what do you get? You get square root of 3 over 2. When everybody look at your unit circle, look at 30 degree angle. What is x? What is y? Look at your 60 degree angle now. What is x? 1/2, and what is y? Okay, they just switch places, don't they? Okay, so they're all 1/2 and square root of 3 over 2. Notice that both x and y are square root of 2 over 2 on which kind of angles? 45 degree angles. Okay, and we actually figured this one out right here. Okay, we got that? Now, the thing you need to know, you guys, let's go back to this right here. The cosine, well, let's start with sine. Isn't that sine written first on your, foldable? Okay, so sine of theta is equal to, in terms of, yes, I'm going to have you write this, but wait till I finish writing it all down, then you guys can write it. Sine of theta is equal to opposite over hypotenuse, right? Okay, but I wouldn't write opposite over hypotenuse again. So that's why I'm saying waiting. But if you look right here, here's theta. Which side's opposite? Y. Which side's which side's hypotenuse? 1. So if we wrote this as y over 1, well, y over 1 is just what? Y. So everybody write on there somewhere on the, I would put unit circle trig. And I would write the sine of theta equals y. I would even, you know what, you could probably even write this whole thing out that I just wrote. Sine of theta equals opposite over hypotenuse, which is equal to y over 1, which equals y. I think that would probably be good to write that whole thing. That is, the y coordinate, you guys, is the value, the y coordinate is the value of the sine function on a unit circle. So whatever y is, that is the value. Got it? Okay, let's do this now. The cosine of theta. Well, in right triangle trigonometry, cosine is equal to what over what? Okay, adjacent over hypotenuse. Okay, I want you to look at on this right here. What is it equal to on the unit circle? X over 1, which is equal to, which is just equal to x. So guess what, you guys? The cosine of theta on the unit circle is just the x coordinate. Cosine of theta is equal to x. We got that one? Okay, the next one. Tangent of theta equals what over what? Opposite over adjacent. Well, what's opposite over adjacent? Y over x. So everybody write tangents equal to y over x. Okay, now flip it over where we have the secant, the cosecant, and the cotangent. These are just reciprocals, right? So for the unit circle trigonometry on the back, what for which one? For a cotangent, what is it? What's the reciprocal of x over y? Y over x. So the cotangent one, you guys, is y over x. The cosecant is the one that goes with the sine. Cosecant is equal to what? 1 over y. And the cosecant is the reciprocal of cosine, so it's 1 over x. Sine is, no, yeah, no, sine is cosecant. So cosecant should be, yeah, 1 over y. Did I say that the other way? I'm sorry. Cosecant, you guys, would be 1 over y, because cosecant's the reciprocal of the sine. Okay, and cosine is the reciprocal of the secant. So secant is going to be 1 over x. Secant over x. We got them all? Do I need to write all those down? Just double check and see if you got cosine of x, a cosine of theta. Cosine of theta equals x. Sine of theta equals y. Tangent of theta equals y over x. Then that would mean the secant of theta equals 1 over x. The cosecant of theta equals 1 over y. And I wrote it as cosine then sine. Probably wrote it in a different order you have in mind. Cotangent is x over y. We got them all? Since they're reciprocals. Okay. That is the gist of the lesson today, you guys, but I want to do some practice problems here and make sure you guys understand how to do it. Okay, we ready? Dylan, were you raising your hand? I'm just trying to balance yourself as you yawned really hard. Okay. All right. Man, you guys look tired today, I have to tell you. Let's do these really quickly. Okay, everybody get out your unit circle. Cosine of a negative 180 degrees. How do you get to a negative 180 degrees? You got to go in the clockwise direction, negative 180 degrees. Where do you end up? You end up at 180, right? And since it is what's the word I'm looking for? Taught you guys about them. Two angles that have the same terminal side are called coterminal. I couldn't think of that name for a second. Coterminal angles. Okay. Since they're since negative 180 and positive 180 are coterminal angles, they're going to be the same, right? Cosine. So what would the cosine of negative 180 be? Dylan says negative 1. Do you guys think he's right? Well, if you look right here at 180, and cosine's defined to be the x-coordinate, right? What's the x-coordinate right there? Negative 1. So everybody write that down, negative 1. Now you got to do the secant of 90 in your notes. You can write some examples on your foldable if you want later on. I'd wait until you organize them a little bit, though. Okay, let's look at the secant of 90. Where's 90 degrees on here? 90 degrees is right here. What is secant defined to be, you guys? 1 over x. Well, what is x? So 1 over 0. Who said undefined? Who said it? All you guys? It is undefined, isn't it? In other words, there is no such thing as secant of 90 degrees. Can't get that one. Okay, the sine of negative 90 degrees. Where would we end up if we went to negative 90 degrees? We would end up at 270. So it's coterminal with 270, right? And it's asking for what is it? The sine? What is sine defined to be? So y. We look at y. What's y right there? So it's negative 1. So we're going to write negative 1 as our answer. Can you guys handle that? Can you handle that? Okay, let's look at this right here. The cosine of 45 degrees. Okay, when you know the answer, raise your hand. Don't say it loud, please. Just when you know the answer, raise your hand. Cosine of 45 degrees. Okay, raise your hand high if you know it right now. I just need to see how many of you know it. Cosine of 45 degrees. Okay, Eric, what do you have? That is exactly right, you guys. If you go to 45-degree angle right here, here's 45 degrees. Cosine's defined to be the x-coordinate, right? You look at the x-coordinate, square root of 2 over 2. So there is my answer, square root 2 over 2. Raise your hand when you know the answer to the sine of 45 degrees. The sine of 45 degrees. You should all have this by now. Okay, Maddie, what do you got? Square root of 2 over 2. Because you go to 45 degrees, sine's defined to be what coordinate? The y, and the y coordinate is square root of 2 over 2. Tangent of 45 degrees. When you know the answer to this one, raise your hand. Seeing how many of you know how to simplify here. Okay, Sean. Rachel said it's 1. That's the easy way to. That's the easy way to say what you were saying. Okay. That's the easy way to say it because what's a number divided by itself? 1. And we had root 2. These guys said root 2 over 2 divided by root 2 over 2. Well, they were exactly right. But when you simplify that, a number divided by itself is 1, or you can think of it this way. Square root of 2 over 2 times, remember when you're dividing fractions, you can change it into a multiplication problem by taking the reciprocal of the bottom one and multiplying it by the top one. Well, if I do that, the 2's cancel out, the square root of 2's cancel out, and you just end up with 1, right? Okay? That's how you do that one. I've got to do one more before I give this, because I want to do the cosine of 30 degrees. Now, you're going to have to do a little simplifying to get this. Oh, no, you don't. Never mind. I was actually, okay. I didn't mean to do that one. What's the cosine of 30 degrees, everybody? Square root of 3 over 2, because it's the x value at 30 degrees, which is square root of 3 over 2. But what if I asked you for the secant of 30 degrees? What is the initial value? 1 over square root of 3 over 2, isn't it? Because it's 1 over x, and x is square root of 3 over 2, right? Well, if I simplified that, all I would do is take the bottom fraction, which is square root of 3 over 2, and flip it over and times it by 1. Well, when you times something by 1, it's just itself, so I get 2 over the square root of 3, right? I got to rationalize that. How do you rationalize it? Times it by square root of 3 over 3, and what do we get? 2 root 3 over 3. And there is my answer to that. 2 root 3 over 3. Got it? Okay. You guys ready for the assignment? This was only half of lesson 5-3. We will do the other half of lesson 5-3 next time. So on your assignment today, I want you to put 5-3 part 1. Please. Please write lesson 5-3 part 1, because if you just put the page number, it's going to be the same page number as part 2, and I will then have to go look at the problems to decipher. And that takes me extra time. So please put part 1.